Today, I will discuss about classification of igneous rocks. I will cover this topic under the following heads: introduction, present classification, mineralogical basis for classification, classification scheme for plutonic rocks, acid igneous rocks, basic igneous rocks, ultramafic igneous rocks, feldspathoids bearing rocks, and volcanic igneous rocks, and lastly the conclusion. Introduction. Igneous rocks are classified on the basis of mineral content, rock chemistry, texture of igneous rocks, and geological setting of the rocks. Every classification in wide use and serve a different purpose. These classifications are based on descriptive parameters. These parameters may or may not have direct genetic implication, but all are useful for purpose of description, communication, and comparison. Direct correlation between mineral and chemical classification is not possible because of the influence of pressure, temperature, volatile content, and rate of crystallization on the mineral species, and solid solution variation in minerals which are present in rocks. An overall subdivision of igneous rocks is based on general occurrences. Volcanic igneous rocks are those formed at shallow depth. They are fine grained to glassy except for coarse grained phenocryst of minerals formed at depth before eruptions. Hypabyssal igneous rocks are intrusive rocks that solidified at shallow depth or nearly 1 kilometer depth. They are normally fine grained, may contain phenocryst, and occur as dikes or silk. Plutonic rocks solidified at depth greater than 1 kilometers. They are medium to coarse grained, extrusive igneous rocks erupted onto the earth's surface, and all volcanic rocks comes under that. Intrusive rocks are subdivided into plutonics and hypabyssal rocks. Present classification. The most recent attempt for uniform classification scheme was initiated by the International Union of Geological Sciences in 1969. The member of the subcommission on the systematic of igneous rocks reported through their chairman Stickinson in 1973, and their findings are the basis of the classification used here. Their work was confined to plutonic rocks. The criteria upon which the classification is based involve the grouping of all minerals into 5 categories. First categories, that is Q denotes quartz, A denotes alkali feldspar, that includes orthoclase, microcline, sanidine, anorthoclase, and albite with anorthite percent 0 anorthite percent 5. P denotes plagioclase, anorthite 5 to anorthite 100%. F denotes feldspathoids, that includes naphthalene, lucite, analcite, sodalite, etc. M denotes mafic minerals, which includes olivine, pyroxene, amphiboles, mica, opaque, etc. There is also a fundamental division of rock into three main categories based on the relative abundance of the mafic and felsic minerals. Thus, first A, that is ultramafic, equal to mainly containing mafic minerals. Second, basic and intermediate, equivalent to mainly contain mafic plus felsic minerals. C, that is acid, mainly contain felsic minerals. As mentioned earlier, one of the major problem is to account for alkali rich rocks. Alkali bearing minerals, mainly potassium and sodium, can occur throughout the whole range from ultra basic to acid. No consensus has been reached on the classification, and the tendency is to use a variety of spatial names. The intermediate rocks also pose certain difficulties since they straddle the boundary between basic and acid. On the basis of mineralogical criteria, it is possible to construct a series of triangles. The various percentage field accounts for the major rocks types. The choice of minerals at the triangle apex is determined as: first, acid igneous rocks consist mainly of light felsic mineral with less amount of mafic minerals. They are classified in term of quartz, alkali feldspar and plagioclase feldspar. Second, basic rocks contain less than 90% mafic minerals and usually more felsic minerals, mainly plagioclase, that is calcium sodium plagioclase. They can be classified in the 5 ways. First, plagioclase pyroxene olivine. Second, plagioclase orthopyroxene clinopyroxene. Third, plagioclase orthopyroxene olivine. Fourth, plagioclase clinopyroxene olivine. And fifth, plagioclase pyroxene hornblende. And third major division is your most but not all ultra basic rocks or also ultramafic rocks, that is based on the relative amount of olivine, orthopyroxene and clinopyroxenes. Now take up the first category, that is acid plutonic rocks. Now see the diagram on screen, that is triangular diagram, which is also known as QAP diagrams. See the different section numbered 1 to 16 and the different rock types we can observe is: first, quartz rich granitoids. Second, alkali feldspar granite. Third, granite. Fourth, adamelite. Fifth, granodiorite. Sixth, transamite. Seventh, quartz alkali feldspar cyanite. 8, quartz cyanite. 9, quartz monjodiorite. 10, quartz monjodiorite. 11th, tonalite. 12, alkali feldspar cyanite. 13, cyanite. 14, monzonite. 15, monjodiorite. And 16, diorite oblique gabbro. If you will see right from alkali feldspar granite towards diorite, the plagioclase, if you will move from there, the plagioclase usually increase and the rock type is your diorite in composition, which is also comes under intermediate category, because in this case plagioclase feldspar is more. If the variety of plagioclase is your calcic sodic, then usually we are moved towards more intermediate type, and if the mafic mineral usually the pyroxenes are present, then that is known as gabbro if plutonic in condition. Now, take up the second rock type for classification, that is your basic plutonic igneous rocks. Classification and nomenclature of gabbroic rocks, plesioclase plus orthopyroxene plus clinopyroxene plus olivine plus hornblende present in major amount along with very minor amount of your biotite, garnet, spinel. Altogether, these are nearly more than 95%. First category is your gabbroic rocks composed of plesioclase, pyroxenes and olivine. Second subdivision of gabbroic rocks into gabbro, orthopyroxene gabbro, clinopyroxene norite, norite, etc. Third, gabbroic rocks that contain hornblende, and these all are based on Stickenson 1976. Now, take up the first classification. See the triangular diagram on a screen based on plesioclase, pyroxene and olivine, and now we can observe the following rock types, that is number 1 anorthosite, second leucogabbro or norite, third olivine leucogabbro norite, fourth leucotractolite, fifth gabbronorite, sixth olivine gabbronorite, seventh tractolite, eighth melagabbronorite, ninth olivine melagabbro or olivine melanorite, 10 melatractolite, 11 plesioclase bearing ultramafic rocks. Second, that is plesioclase, orthopyroxene, clinopyroxene. These assemblies usually present in all important basic igneous rocks. Now, see the triangular diagram on a screen. We can see or observe the different rock types, which are first anorthosite, second leuconorite, third clinopyroxene leuconorite, fourth orthopyroxene leucogabbro, fifth leucogabbro, sixth norite, seventh clinopyroxene norite, eighth orthopyroxene gabbro, ninth gabbro, 10 melanorite, 11th clinopyroxene melanorite, 12th orthopyroxene melagabbro, 13 melagabbro, 14 plesioclase bearing pyroxenites. Now, third C category, that is plesioclase, orthopyroxene, olivine. Now, we can observe the different rock types. First, based on triangular diagram, first anorthosite, second leuconorite, third olivine leuconorite, fourth leucotractolite, fifth norite, sixth olivine norite, seventh tractolite, eighth melanorite, ninth olivine melanorite, 10 melatractolite, 11th plesioclase bearing ultramafic rock. Now, D, the main composition is your plesioclase, clinopyroxene, olivine. If you will see the triangular diagram on the screen, now we can observe the different rock types, that is your anorthosite, second leucogabbro, third olivine leucogabbro, fourth leucotractolite, fifth gabbro, sixth olivine gabbro, seventh tractolite, eighth melagabbro, 9 olivine melagabbro, 10 melatractolite, 11th is your plesioclase bearing ultramafic rocks. Now, next important assemblies, if hornblende present in basic igneous rocks, then we can draw the triangular diagram based on plesioclase, pyroxene and hornblende. On the basis of the triangular diagram, we can observe the different rock types, that is first anorthosite, second leucogabbro or norite, third pyroxene hornblende leucogabbro or norite, fourth hornblende leucogabbro, fifth gabbro or norite, sixth pyroxene hornblende gabbro or norite, seventh hornblende gabbro, eighth malagabbro or norite, ninth pyroxene hornblende malagabbro or norite, 10 hornblende malagabbro, 11th plesioclase bearing pyroxenite, 12th plesioclase bearing hornblende pyroxenite, 13 plesioclase bearing pyroxene hornblendite, and 14 plesioclase bearing hornblendite. Now, the third major classification, that is your ultramafic rocks. Classification and nomenclature of ultramafic rocks, mainly the main important minerals which are present in ultramafic rocks are olivine, orthopyroxene, clinopyroxene, hornblende, and with minor amount of biotite, garnet, spinel, altogether more than 95%, opaque mineral less than 5%. On the basis of the mineral present, we can divide the ultramafic rocks into two major types. First, ultramafic rocks composed of olivine, orthopyroxene, and clinopyroxene, and second, the ultramafic rocks that contain hornblende is Stringenson 1976. Now, take up the first group based on the mineral assemblages olivine, orthopyroxene, clinopyroxene. Ultramafic rocks mainly two major types, first pedotites and second pyroxenites. The ultramafic rocks which contain nearly 40% olivine comes under the pedotite categories, and on the basis of olivine, orthopyroxene triangular diagrams, we can observe the different rock types, which are first dunite, second Herzbergite, third lahajolite, fourth whorlite. Altogether, right from number 1 to 4, all comes under pedotite categories. Fifth, olivine orthopyroxenite, sixth, olivine websterite, seventh, olivine clinopyroxenite, eighth, orthopyroxenite, ninth, websterite, and 10 clinopyroxenites. Right from your number 5 to 10, that is olivine orthopyroxenite to clinopyroxenite, all these rock types comes under pyroxenite categories. Now, take up the second part, which is the mineral which contain usually in ultramafic rocks, that is your olivine, pyroxene, and hornblende. On the basis of triangular diagrams, we can observe the different rock types, which are number 1 dunite, second pyroxene pedotite, third pyroxene hornblende pedotite, fourth hornblende pedotites, fifth olivine pyroxenite, sixth olivine hornblende pyroxenite, seventh olivine pyroxene hornblendite, eighth olivine hornblendite, ninth pyroxenite, 10 hornblende pyroxenite, 11th pyroxene hornblendite, and 12th hornblendite. The basic rock classification on the basis of mineral present, we have already observed, that is plesioclase, pyroxene, both pyroxene, clino and orthopyroxene, olivine and hornblende. These are the major important minerals usually we can observe in basic igneous rocks. And important rock types we observe, especially your anorthosite, norite, gabbro, tractolite, and hornblendite. If you will join the ultramafic rock classification, that is based on olivine, orthopyroxene and clinopyroxene, if we will join the two epochs with basic classification, that is olivine and orthopyroxene line with the triangular diagram with your olivine, orthopyroxene and plesioclase. Similarly, the olivine clinopyroxene line, if you will join with basic classification, that is olivine, clinopyroxene and plesioclase, and downside, that is your clinopyroxene and orthopyroxene line, if you will join with triangular basic diagrams, that is your orthopyroxene, clinopyroxene and plesioclase. Now we can see in center the olivine orthopyroxene, which is ultramafic igneous rocks, and all three corner sides we can observe the different basic igneous rocks. On the basis of depth, we can see that ultramafic rocks which are occur at greater depth with high temperature, where the volatile is very less and crystallization rate is very slow. With influx of SiO2, it means when magma move towards upper side, the SiO2 react with olivine and olivine change into pyroxenes, and usually the plesioclase also occur at slightly lower temperature and depth as compared to ultramafic igneous rocks. Now we can observe the different ultrabasic igneous rocks, that is known as tractolite. Both tractolite we can observe it in clinopyroxene, even in orthopyroxenes. So on the basis of this diagram, we can conclude the ultramafic rocks is just like a primitive igneous rocks which evolved and give rise to primary igneous rocks or derivative igneous rocks. The ultramafic igneous rocks classification, that is mainly based on your olivine, orthopyroxene and clinopyroxenes. If suppose you will see right from your dunite to Harisingh, lahergolite and weyerlite, especially the lahergolite, we can see the different composition bearing lahergolite, especially the spinel lahergolite, garnet lahergolite, and even in sometimes we can see the kyanite bearing lahergolite. Especially in ultramafic rocks, even we can observe micro diamonds if they are associated with kimberlites. So these ultramafic rocks are very important because they contain high Mg composition and mainly the dunite bearing rocks. These four, right from your dunite, Harisingite, lahergolite and weyerlite, all these are comes under pedotitic composition or also known as pedotitic rocks. Even in sometimes we can also observe in these rocks the hornblende bearing. It means the activity of water is slightly higher as compared to previous category where the olivine and only pyroxenes are present. And if hornblende is present, it means we are slightly moving upwards so that the activity of water is increased and pyroxene plus water react and form amphiboles. Now take up the next IUGS classification, that is for acid volcanic igneous rocks. On the basis of QAP diagrams, we can observe the 6 important rock types. Number 1, rhyolite; second, rhyodacite; third, dacite; fourth, trachyte; fifth, trachyandesite, that is also known as latite; and sixth, andesite. Now, next important IUGS classification, that is for undersaturated plutonic igneous rocks which contain feldspathoids bearing rocks. Now, the first, on the basis of FPA diagram, that is feldspathoid, plesioclase, alkali feldspar diagrams, triangular diagrams, we can observe the different rock types. Number 1, isolite, naphlinite, lucitite, phonolite or tephritic. Mainly, if naphthalene dominated, then it will be known as naphlinite; lucite dominated, known as lucitite. Second, naphthalene diorite or gabbro, tephritic or basanite. Third, naphthalene monjodiorite or monjo-gabbro, phonolitic, tonzimitic basanite. Fourth, naphthalene monjocyanite, tephritic phonolite. Fifth, naphthalene cyanite. Sixth, naphthalene bearing diorite, andesite, gabbro, basalt. Seventh, naphthalene bearing monjo-gabbro, basalt. 8, naphthalene bearing monzonite, latite. 9th, naphthalene bearing cyanite, that is also known as trachyte. 10, naphthalene bearing alkali feldspar cyanide, trachyte. Now, take up the next modules, that is conclusion. In this modules, we have discussed about the present classification for igneous rocks, that is IUGS classification for acid, basic, ultramafic, volcanic, acid and feldspathoid bearing rocks. The IUGS classification provides the clear idea about the varieties of igneous rocks, especially the plutonic igneous rocks. Thank you very much.